Right, in today's lesson, we're trying to make sense of negative exponents and how do we work with them. And before we start, I'd like you to copy this. You're just going to pause the video and copy down everything you see here. This is 5 to the power of 4, 3, 2, 1, 0, all the way down to 5 to the power of negative 4. And what does the negative exponent mean? Remember, it meant 1 divided by 5 times 5 times 5 times 5. So if I were to pull out my calculator, how did I get that number 0.0016? I did 1 divided by 5, divide by 5 again, divide by 5 again, divide by 5 again. I do that 4 times, and I see I come up with the number 0.0016. So pause the video and then come back as we work with these negative exponents. So I'm going to go through 4 examples, and I'm going to go back and forth between these answers in our example. So I'm going to start on my example. And notice how on the notebook I've got these on the left side so I can reference them quickly. And I'm going to work my examples on the right side. So example 1 is going to be 5 to the power of 4. And I'm going to multiply that times 5 to the power of minus 3. So there's that negative exponent, and how do I deal with that? And what we're going to do is go straight to the numbers here and do the math that way. So 5 to the power of 4 up here is 625. So what we're really doing is multiplying 625 by minus 3 was this number over here, 0.00. Let me scoot this over a tiny bit. 0.008. See where I got those numbers from? The 625 was 5 to the power of 4th, and then the 0.008 was 5 to the minus 3. So I'm stealing these numbers over here. And now I'm going to pull out my calculator, and I'm going to multiply those two numbers together, and watch what I get. I'm going to multiply 625 times 0.008, and my answer is 5. That's what I get when I multiply those two numbers. And if I look over here, here's the 5, and that was actually 5 to the power of 1. And so I say that when I'm multiplying those, I actually get 5 to the power of 1. Where'd that 1 come from? What's another way to do it rather than converting these into the numbers and multiplying? And where that 1 came from was when we multiply, we add exponents. So that came from doing the 4 plus the negative 3. This 4 plus that negative 3, or 4 minus 3, that's where the 1 came from. That's why it equals 5. So let's go to a second example. Pause this video if you want to think about this and try and make sense of it. Our next example is going to be 5 to the power of negative 1 multiplied times 5 to the power of negative 2. And again, what I'm going to do is I'm going to go back over here to what those things equaled, right? So I got 5 to the power of 1 here. What does it equal? Is the number itself 5. So I'm going to go over here, and this means then 5 times, and 5 to the minus 2. What is 5 to the power of minus 2? I did it over here. It equals 0.04. So I'm going to go 5 times 0.04. That's really what I'm doing. And so I go and I grab my calculator, and I'm going to do 5 times 0.04. 5 times 0.04. It ends up equaling 0.2. This equals 0.2. And you're going to see back over here, well, what is that as an exponent? 0.2. Which one was it? Oh, here, 0.2, 0.20. That was 5 to the power of minus 1. So this answer here is 5 to the power of minus 1. That's how I multiply those exponents, because 0.2 is 5 to the power of minus 1. Where did the minus 1 really come from? What was I actually doing if I use exponent rules? I was adding them, the 1 plus the negative 2. And 1 plus negative 2 equals negative 1. That's why my answer is 5 to the power of negative 1. Now notice the base doesn't change ever. When I'm combining, multiplying, dividing exponents, this 5 is always there. And a lot of you have been wanting to multiply the 5 times the 5 to get 25. No, the base always stays the same. It's the exponent that's changing. So now let's take a look at what does it look with division. So I'm going to do problem 3, and we're going to do a division problem. 5 to the power of 1 over 5 to the power of minus 2. And what will that look like? And again, I want to go back to these answers here to do the math on a calculator to make sense of what's going on. So 5 to the power of 1 is 5, and 5 to the power of minus 2 is 0.04. So I'm going to do that this equals 5 to the power of 1 was 5, and I'm dividing it by 5 to the power minus 2, which is 0.04. And this is a division problem. So when I go do that on my calculator, what I'm doing is 5 divided by 0.04. So I got 5 divided by 0.04. And what does it equal? It equals 125. It equals 125. Well, let's go look over there. What power, what exponent was 125? And I see up here, the answer 125 is 5 to the power of 3. See how that base never changes? So my answer over here, this 125, is really 5 to the power of 3. Now, how did I get that 3 just looking at these exponents? Notice, the base never changes, just the exponent. And this 3 came from, when we find out when we're dividing, that we actually subtract instead of add. And so it came from doing this, 1 minus a negative 2. And when I subtract, that's the same as saying 1 plus 2. Subtracting a negative is the same as adding it. That's where that 3 came from. So I got to just look at this problem and go, oh, well, this is 1 plus that 2. That's my answer. Okay, let's take a look at one last example, and then we'll go into our book and try some problems from there. So example 4, and I'm going to do, excuse me, 5 to the power minus 1 over 5 to the power of minus 4. And again, this answer is going to land up being 5. The 5 won't change, to the power of something. Can you make sense? What are we doing here? What will this land up being? And we're going to go back to our numbers to do it with a calculator to make sense of this. So 5 to the minus 1 was 0.20, and 5 to the minus 4 was a really small number, 0.0016. So we'll write these down. And what I have is 5 to the minus 1 was 0.20, and I'm dividing it by 5 to the minus 4, or 0.0016. So go do this on your calculator. I'll pull my calculator out. I'm doing 0.20 and dividing that by 0.0016, and I'll end up getting 125. This answer equals 125. So what is that exponent on here now? Well, where is 125 on here? It's one of those exponents. And I see that here it is, 125 is 5 to the power of 3. And so this was 5 to the power of 3. And where did the 3 come from? How are I doing it with exponent rules? Well, when we're dividing exponents, we find that we subtract the exponents. Keep the base. So this is a little weird. Negative 1 minus a negative 4. And that lands up just being negative 1 plus 4, because subtracting a negative is positive. And that's where the 3 came from, minus 1 plus 4. So let's go into the book and do some examples there, but here's just kind of just an introduction on how to do these. Thank you.